Good afternoon, everyone.
Good afternoon, sir.
Let us start. Remember, we have been learning Chapter 3, Interior of the Earth. Yesterday, we learned about structure of the Earth, types of volcanoes, and today we shall discuss about volcanic landforms. Volcanic landforms, and we shall discuss mainly about intrusive forms, now let us read. The lava that is released during volcanic eruptions on cooling develops into igneous rocks. Okay, so after cooling lava, igneous rocks are developed, that we have learned. And the cooling may take place either on reaching the surface or also while the lava is still in the crustal portion. The cooling of lava may take place either on the surface of the earth or in the interior of the earth. Depending on the location of the cooling of lava, igneous rocks are classified as volcanic rocks, that is cooling at the surface, and plutonic rocks, that is cooling in the crust. Okay, and the lava that cools within the crustal portion assumes different forms, and these forms are called intrusive forms. Okay, the lava that cools within the crustal portion assumes different forms, takes different shapes, and these different forms are known as intrusive forms. Okay, see, let me repeat. We have learned that the lava that is released during the volcanic eruption on cooling develops igneous rocks. And see, this is the surface, and here we have the crustal portion is here, and this is the mantle, asthenosphere, upper mantle, and here we have a magma chamber, and from here magma may rise upwards, okay, and maybe ejected on the surface, and after cooling the lava here on the surface, igneous rocks are formed. And these also can be cooled down. Okay, lava also, the magma or the lava also can be cooled down in the earth interior, here in the earth interior, in the crustal portion. Okay, so if it is cool inside the earth, okay, inside the earth, that is in the earth interior, the rock that is formed here is known as plutonic rocks. Okay, and the rocks which are formed after cooling lava on the surface of the earth is known as volcanic rocks. Okay, as mentioned here. See here, cooling may take place either on reaching the surface or while the lava is still in the crustal portion, and depending on the location of the cooling of the lava, igneous rocks are classified is volcanic rocks, that is cooling at the surface. And if it is cool in the earth crust, we call it plutonic rocks. Okay, and the lava that cools within the crustal portion assumes different forms, and these forms are called intrusive forms. Okay, so now we shall discuss about different intrusive forms. And here this is a block diagram, okay, depicting different intrusive forms. And now let us continue. So the first important intrusive form is Batholith. Let us read. A large body of magmatic material that cools in the deeper depth of the crust develops in the form of large domes. They appear on the surface only after denudation processes remove the overlying materials. Means after the surface has been eroded, okay, the intrusive forms will be exposed on the surface, and they cover large areas and at times assume depth that may be several kilometers. And these are granitic bodies. This granite, is a type of this igneous rock. Batholiths are the cool portion of the magma chambers. Okay, batholiths are the cool portion of the magma chambers. So here is this magma chamber, okay, say after cooling may take the shape of a large domes also, and it is mostly formed deep into the earth interior. Okay, now let us see a diagram. See here, this is magma chamber. Okay, this is magma chamber, but if this upper portion of the magma chamber is cooled down, then batholiths will be formed. Okay, see here we have the magma chamber, and if this portion of magma chamber is cooled down, then an intrusive is formed, and that intrusive is known as batholith. Okay, as mentioned here, these batholiths are the cool portion of magma chambers. Magma chamber means that chamber, okay, that layer, that chamber, this filling with magma, that is the hot molten material. And this most of the time takes a large domes. Okay, it takes the shape of a large domes, and this is another batholith. Okay, and here we have this after erosion. Okay, after erosion these surface areas, okay, these batholith will be exposed on the surface. That I will show you one photograph. Okay, this is an example of batholith. Okay, see here, this portion was once under the ground, okay, in the earth interior. Due to erosion, it has been exposed on the surface, and this is an example of a batholith. Any question from your side about meaning of intrusive forms, then about this batholith? Actually, batholith is an intrusion, okay, which takes the shape of a large dome, and it is formed in the earth interior after cooling the magma chamber. And due to denudational processes, due to the erosional processes, this intrusive form may be exposed on the surface, okay, in the form of a large dome. Any question from your side?
No, sir.
Okay, then let us continue. Then see next intrusive form is Lacolite. These are large dome-shaped intrusive bodies with a level base, okay, and connected by a pipe-like conduit from below. It resembles the surface volcanic domes of composite volcano, only these are located at deeper depths. So this Lacolite looks like surface volcanic domes, okay, of composite volcano, but the only difference is that it is located deep in the earth interior, and it can be regarded as a localized source of lava that finds its way to the surface. Okay, now let us see let us look at that diagram. See here, Lacolite is here. Okay, I think you are seeing that this base is flat, level. Okay, see, as mentioned here, it is mentioned here, these are large dome-shaped intrusive bodies with a level base connected by a pipe-like conduit from below. Okay, as here, see here, Lacolite is here, and see, the base is level and it is connected by a large pipe, okay, conduit. So this is Lacolite. Okay, and here this we have a photograph of Lacolite. Okay, so once it was under the ground, but now it is exposed on the surface. Okay, so it is a large dome exposed on the surface, and this is known as Lacolite. Okay, next we have these other intrusive forms like Lapoli, Facolite, and shields. Let us read. As and when the lava moves upwards, a portion of the same may tend to move in a horizontal direction whenever it finds a weak flame. Okay, and it may get arrested in different forms. So whenever magma rises, okay, whenever this magma rises from the magma chamber, if it finds these weak areas, okay, it may tend to spread horizontally like this. It may tend to spread horizontally like this, taking different shapes. Okay, that is the point mentioned here. In case it develops into a saucer shape concave to the sky body, it is called Lapolite. In case the intrusive form looks like a saucer shape concave into the sky body, it is called Lapolite. Okay, see here, if it is concave, let me draw another one. Okay, see here, this is the crustal portion, and here lies the magma chamber, and here we have the conduit, and see here, if the intrusive form is like this, concave to the sky, okay, like this is called concave. Okay, I think all of you have learned about lens in class 10. So concave to the sky, this is known as what? This is known as a Lapolite. Okay, so here we have a diagram also here. Lapolite. See here, saucer shape Lapolite. Okay, see, this is concave to the sky. Lapolite, same thing. Okay, so this is Lapolite. So this is the main conduit, and it is intruded horizontally and taking the shape of a saucer concave to the sky, and this is known as Lapolith or Lapoli. And see, we don't have photographs about this Lapoli. Okay, so let us continue. A wavy mass of intrusive rocks at times is found at the base of synclines or at the top of anticlines in the enfolded igneous country. Such wavy materials have a definite conduit to source beneath in the form of magma chambers, subsequently developed as batholith, and these are called facholiths. Okay, see, facholith is a wavy mass of intrusive rocks. At times it is found at base of the synclines or at the top of anticline in the folded igneous country. So now let me draw first. Let us say this is a folded country, okay, a folded mountain range. So these are the different formations, different layers. These are the different layers or the formation. Okay, formation is a layer formed in a particular geologic time. And see here, this is known as anticline. Okay, this is called anticline, and here this is known as syncline. This is known as syncline. And see facholiths. Okay, facholiths are found here. Here is the at the uphold of the this anticline, here or here. Okay, it may be formed here in this area. Okay, as mentioned, see here. A wavy mass of intrusive rock at times is found at the base of synclines or at the top of anticline in folded igneous country. Okay, here. See, either at the anticline, okay, on the top of the anticline here, or at the base of the syncline. And these are known as facholiths. Okay, these are known as facholiths. See here, in this area you'll find, see here, facholith is here, and here at the syncline also you'll find facholith. At the anticline also we find facholith. And this is a photograph of facholith. Let us continue. The near horizontal igneous rocks are called sills or sheath, depending on the thickness of the material. That means if the magma is intruded horizontally, okay, the thinner ones, it is known as sill or sheath. If it is thin, okay, it is known as sheath, and while the thick horizontal deposits are called sills. That means sills are horizontal igneous intrusions. Okay, so let me say here we have this here. From this magma chamber, magma is intruded horizontally. See here, sill. So this is also another sill. It is here, okay, it is here. Here, from here, magma is rises upward and it is intruded horizontally. Okay, and so this is known as sill, and this is also known as sill. The thinner one is known as sheath. If it is thick, we call it a sill. But sheath or sill, these are horizontal intrusions. Okay, spread horizontally. And here we have a photograph of sill here. Okay, see here, these black areas, this layer, a thick layer of these black this thick black layer is an example of sill. Okay, this is sill. And last we have dikes. When lava makes its way through cracks and fissures developed in the land, it solidifies almost perpendicular to the ground, and it gets cooled in the same portion to develop a wall-like structure, and such structures are called dikes. Okay, such structures are called dikes. That means dikes are vertical intrusions. Okay, see here, if it is intruded, if it is say this is the layer, and if here it is, if it is intruded vertically like this, just like a wall, and this is known as a dike. So we may see the diagram here also. Okay, this here. So on the surface you will see dike like this, but here this is dike. Okay, this vertical intrusion, this is dike, and here also you're seeing this is a dike. Okay, just see a clear one. Okay, see here, this is dike, this vertical intrusion is dike, and here this is also dike. On the surface you will see dike like this, and this is also dike. Dike means vertical intrusions. Okay, and here we have a photograph of this dike here. Here you will see that this dark color, okay, dark color intrusion you will see here in this photograph, and this is dike, and this is also another one. This is also dike, this is also dike. Any question from your side about the intrusive forms, boys and girls? Any question regarding different intrusive forms? Okay, then so see, let us do this activity. Okay, locating an epicenter. Epicenter, you know, the surface on the earth vertically above the focus is known as epicenter, that we have learned in the previous classes. Okay, how to locate an epicenter? Now let us do it. Okay, so what we need is, we need data from 3 seismic stations. Okay, we need data from 3 seismic stations about the time of arrival of P and S wave, and it is already given here. So we have got the data here. So here this is the arrival time of P waves and S waves in hours, minutes, seconds. Okay, so we have got the data. Then how to locate? So here is the procedure. So number one, what to do? Find the time interval of P and S waves. Okay, find the time interval of P and S waves of given earthquake for the 3 stations for which you have the data. So we have the data, and we have to find out, okay, this time of arrival of P and S wave, and then compute the time lag between the arrival of P and S wave for each station, and it is called time lag. So after getting the data, after collecting the data of the arrival time of P and S wave, so we have to find the time lag. So we have to subtract, okay, the arrival time of this P and S wave. Okay, arrival time, we have to subtract the arrival time of S wave from the P wave, like that. And the basic rule, okay, so here basic rule, for every second of time lag, the earthquake is roughly 8 kilometers away from us. Okay, the earthquake is roughly 8 kilometers away from us. Then using the rule given above, convert the time lag into distance. That is seconds of time lag multiplied by 8. So here we have the solution here. So from the data here we are computing the time lag. Okay, say from this data, so from this data, so this table shows the arrival time of P waves and S waves, and from this data we are computing the time lag. Okay, so this is the time lag of station 1. Okay, see here, this we have a time lag of 1 minute and 25 seconds. Just see here. Okay, 3 hours 23 minutes 20 seconds. This is the arrival time of P waves, and here the arrival time of S wave is 3 hours. Okay, then 24 minutes and 45 seconds. So 3 minus 3 0. Okay, then 24 minus 23 1, that is 0.1 minutes, and 45 minus 20, that is 20 seconds. Okay, so in this way we have got like this. So 00 hours 01 minute 25 seconds. For the station 2 we have like this, 01 minutes and 40 seconds for the station 2. Then for the station 3 we have again 01 minutes and 55 seconds. After this we have to convert this time lag. Okay, this time lag means time difference. So this time lag we have to we have to convert it into distance. How to do it? So for the station 1, see, we have to convert this minute into seconds. So we have 60 seconds in a minute, and that is why 1 into 60, that is 1 multiplied by 60 plus 25. Here this 25. So it becomes 85. So the time lag in seconds for station 1 is 85. And after that we have to find out the actual distance, that is the distance on the ground. So here we have the formula, seconds of time lag multiplied by 8 kilometer. So you have to remember the basic rule. For every time lag of 1 second, we are 8 kilometers away. With that rule, okay, we have to calculate it. See, time lag in seconds, 85 seconds into 8 is equal to 680 kilometer. Okay, then after that we have to find out distance on the map. Here, according to this textbook, the scale given here is 1 centimeter is equal to 40 kilometer. That means a distance of 1 centimeter on the map represents a distance of 40 kilometers on the ground. What to do? We have to divide this 680 kilometer by 40 kilometer. After that, you will get the distance on the map. So 17 centimeter is the distance on the map, and 680 is the distance on the ground. Okay. And likewise for station 2, again, see, we have to convert in the time lag in seconds. That means here we have 1 minute, so 1 into 60 seconds plus 40 seconds, it becomes 100. Then 100 seconds into 8 kilometer, we have got 100 kilometer. Then divided by 40, it becomes this 20 centimeter. Likewise for S3, station 3, okay, seismic station 3, again we have to find out time lags in second. That is 1 into 60 plus 55 seconds. We have got 115 seconds. Then after that we have to calculate the actual distance on the ground. That is 115 seconds multiplied by 8 kilometer, that is 920 kilometer, divided by 40 kilometers. So we have got 23 centimeter. This is the distance on the map. So in this way we have to find, okay, distance on the map. Then what to do on the map? Okay, after this step 4, on the map locate the seismograph stations. On the map we have to locate these seismograph stations. Then draw circles taking the seismograph station as the center with the radius equal to the distance you have calculated in the previous step. And these circles will intersect each other at a point, and this point is the location of the epicenter. See here we have S1. This is just an example, okay. This is seismic station 1 we are locating on the map, okay. See here I am again representing like this. So here we are locating the this seismic station 1 here, okay. S1 we have located here, S2 we have located here, the seismic station 2 is located here, station 3 is located here, and with this value, okay, with this value as the radius we are drawing a circle here, okay. So this is S1, location of S1 as the center, and the 17 centimeter as the radius we are drawing a circle. And likewise for the S2 also, it is located on the map, and with 20 centimeter as the radius we are drawing a circle here. And likewise we have to do the same for the S3 also. First we have to locate on the map, and 23 centimeter as the radius we are drawing a big circle. And all these circles are intersected here, okay. All the 3 circles are intersected here, and this point where all the 3 circles are intersected is the epicenter, is the location of the epicenter, okay, as indicated here. So in this way this epicenter is located. However, you must know that this is the simplest form, okay. This is the simplest form of locating in epicenter. Nowadays we don't use this technique. See, in the normal practice the epicenters are located using computer models, okay, and a GPS system also. So we're using these different softwares, okay, and analyzing these seismic waves, then distances, and a GPS system. So it is very easy and very quick also, okay. But this is the basic, okay. This is the principle. See, the procedure outlined here is much simplified version of what is normally done, although the principle is the same. This is the basic, and in this way we can locate epicenter of the earthquakes, okay. Now do you have any question about the activity, location of the epicenter, or about the various intrusive forms? Do you have any question? Yes. Are you connected?
Yes, sir. Yes, sir.
Then means you don't have questions. Are you clear?
Yes.
Okay, the first part is about definition of intrusive forms. Okay, I think all of you have learned how igneous rocks are formed. See here, the lava that is released during the volcanic eruption on cooling develops igneous rocks. That means igneous rocks are formed after cooling lava, and this cooling process may take place either on the surface of the earth or in the earth interior. Sometimes the lava is not able to eject on the surface and it is cooled down in the earth interior. Okay, or when it is ejected on the earth surface, again it is also cooled down. And if the lava is cooled down in the earth interior, okay, it is known as plutonic rocks. If the lava is cooled down, in the earth interior and form igneous rock, that is known as plutonic rock. And if the lava is cool on the surface and if an igneous rocks are formed, we call it volcanic rocks. Okay, if it is formed on the earth surface, we call it volcanic. If it is formed in the earth interior, we call it plutonic rocks. And if lava cools within the crustal portion, okay, it takes different forms, it takes different shapes, and these forms, okay, these forms of magma or lava in the earth interior, okay, are called intrusive forms. Okay, these are known as intrusive forms, as given here. See, Batholith is an intrusive form, Dike is an intrusive form, okay, as given here. See here, just you may see this diagram, okay, and here. So these are the different intrusive forms. If it is vertical, okay, it is known as dike. If it is horizontal, it is known as sill. If it is in the dome shape with level base, we call it Lacolite. If it is concave to the sky, we call it Lapoli. Okay, if the magma chamber is cooled down and form a big dome in the earth interior, we call it Batholith. Okay, so these are the different intrusive forms. Any other question? Okay, if you don't have other questions, so let us stop here for today. Please don't forget to send your names in the WhatsApp group for attendance. Thank you very much for joining my class.